I'm a smart contract developer. I work in Notional Finance. It's a DeFi protocol, specifically fixed rate lending and borrowing. I'm very into DeFi. I like smart contracts kind of power everything from DeFi to NFTs to DAOs and everything, right? Like everything that we do in Web3, they all depend on smart contracts in some form or shape, right? So it's good to obviously have some understanding of what they are and what they can do and what they cannot do, which is important, right? So let me share my screen. Oh, I can't.
Yeah, sorry. I'm going to give you the cohort. Sorry.
Yeah. Okay. All right. So I prepared some slides, but I'll basically just talk to them. So yeah, so this is really just introduction. You're not like it's. I don't want to get too technical with this session. So if you want to know more about this stuff, you can we can maybe talk offline, or there's a group that I put together, and we can talk about this stuff in depth. So what are smart contracts, right? So smart contracts are really just compiled code that's stored on a blockchain. So it requires a blockchain to work, right? Like you have to, and the most prominent smart contract platform right now is Ethereum, which I happen to know the most about. And an example of a smart contract, I have a link here, right? This is the wrapped Ether contract, and you can look at the verified source code. It's a very old Solidity version, but Solidity is the programming language that's the most common for developing smart contracts. You can use something called Viper, which is a different programming language, but I'm only aware of a single project, Curve Finance, that's using Viper. Every other project is using Solidity, so that's the most common one for sure. And what's actually deployed on the blockchain, which is important to know, is the bytecode, right? So it's the machine code that EVM understands, the Ethereum virtual machine, right? The source code is not on the blockchain. Okay, so only the bytecode is on the blockchain. Very important. Now the contract functions. So the way you interact with these contracts is by calling contract functions. And the way you do that is by sending transactions to these contract addresses, right? So when you create a contract, for example, this is a contract creation transaction, right? No, not this one. Sorry, not this one. This one. So when a contract gets created, an address is generated. And this address you can use to interact with the contract. Now, this address is derived from the deployer address and the nonce and everything, which means that it really doesn't have a private key, or at least we don't know what the private key is. So that's an important thing that you have to remember. We'll get to that later. What you do is you send transactions to this address. That's how you invoke functions. So you can do it from an EOA, an externally owned account, basically accounts with private keys. So kind of like your MetaMask. So in the Ethereum ecosystem, you have two types of accounts. You have EOAs with private keys, and you have contract accounts without private keys. Now, the contract functions are exposed through something called an ABI. So what an ABI is basically a description of what the functions are. So for example, like if you format the stuff nicely, you'll see like a lot of the functions like deposit, right? Like deposit and withdrawal and things like that, right? Which they all correspond to like these functions that are defined. So the ABI is what you use to interact to know what kind of payload you need to give to the contract in order for it to work. It also gives you the names of different functions, but the functions are kind of done through selectors, not really names. So that's something we can talk about later, but just keep that in mind. Now, the contract source code can also be verified, right? So for example, right, if only this is deployed on the blockchain, how do you know that this code is really that? Eh? Now, so that's done through something called contract source code verification. So what you do is you take this code, you use this compiler version, you turn off the optimization, EVM settings, and everything. You compile this, and you should get the exact same bytecode. If you do, it's verified, right? That's what Etherscan does, and there's a little check mark. It means they have done the work. You can do that independently if you don't trust Etherscan, which you really shouldn't, right? So if you don't, the one key thing in the blockchain space is never trust anything. Always verify, right? So compile this code with these settings, and the constructor parameters, you need that as well. But in this case, I don't think there's there's no constructor. So yeah. So you should get the same bytecode, right? That's verification. So a good analogy in the real world for a smart contract is a vending machine, right? So it's self-contained, has a set of rules scripted into the machine itself. You send a transaction or make a deposit, and some like a can of Coke comes out or something, right? Like it's well defined. It's once it's deployed, it's basically done forever, right? Like, well, vending machines are a little bit different, but like smart contracts are immutable. So what are some of the benefits? Like, why do we even need this stuff, right? So first of all, smart contracts really allow unrelated anonymous parties to conduct complex transactions without the need to trust a central authority, right? So you can essentially make API calls essentially to these contracts, and these contracts are not really controlled by a central party, right? Like when you make an API call to Facebook, they can change the rules at any time. If you make a AWS call, they can also change the rules, but smart contracts never change, right? Smart contracts are non-custodial by default. They have no private keys, which means they cannot just do things. Okay, so anything that a smart contract can do needs to be spelled out in the contract code for everybody to see. So there is nothing there's nowhere to hide, right? Nothing fishy can happen. They're also immutable once they're deployed, which means once this is on the blockchain, it's done, over, right? Nobody can go in there and change this stuff. This is permanent on the chain, right? You can deploy another one, but you can never change this code. This is done. The transactions are atomic, which means that when your transaction is executing, the state doesn't change. Like it's not going to change outside of your control. That's important because it opens up the possibility of flash loans. That deserves its own session. I deal with flash loans on a daily basis. We can talk forever about flash loans. The security is provided by the underlying blockchain, right? In the case of Ethereum, security is provided by the Ethereum blockchain. The smart contract EVM is really an execution layer on top of that, right? The consensus and everything is provided by the blockchain. I'm not going to go too deep into blockchain technology itself. I assume that works. It's kind of like your operating system. It works, right? You like Linux works. You write applications on top of Linux. That's what we do. Now the rules are actually enforced by code, right? There's no need for courts and lawyers. I mean, why do you even need lawyers when code dictates whatever outcome that happens, and there's no way to change that, right? So there is no wiggle room. Like the reason you need the court system or the legal system is there's always some wiggle room, right? With code, there's no wiggle room. It's non-compromising and it's absolute, right? And there's no counterparty risk, right? So whatever you do in DeFi, you know that the other party is not going to run away because the code will allow you to sell their collateral if they do decide to run away. Now, so great benefits, right? Pretty awesome. We need to talk about the limitations. It's not all hype, okay? So what are some of the problems with smart contracts? Very important, right? First of all, they always require externally signed transactions because they have no private keys, right? Because smart contracts have no private keys, they always require an external trigger. So somebody somewhere has to initiate that transaction from an externally owned account or an account with a private key. So in other words, you cannot do automated tasks with smart contracts alone. There has to be a transaction that triggers that smart contract that's off chain, right? So that's, you need to remember that, right? Like a lot of people say, hey, why can't we just do something that runs periodic? Yeah, that ain't gonna happen with smart contracts. Okay. Getting off-chain data is actually quite difficult. Okay, so this is something that's can be a problem, right? Like for example, a lot of the DeFi contracts require external like price information. That's not always easy to get, right? Like on-chain information can potentially be manipulated through flash loans. Off-chain data, you kind of have to get through like Chainlink, and but then you have to trust Chainlink, and there's the Oracle network, right? So that opens up like another can of worms. Right now, really like DeFi, I feel like they're placing too much trust on Chainlink, which in my opinion isn't always a good thing, but we need to really look into that side of things and figure out how to safely and securely get off-chain data into smart contracts without having to trust too many things, right? Like smart contracts are completely self-contained. They cannot make API calls to, by the way, right? They cannot make API calls to traditional services. The way Chainlink works is kind of different. We can talk about that offline, but just keep that in mind. Very difficult to get off-chain data. Okay, any data that's not sitting on the blockchain, very difficult to interact with. They're extremely difficult to develop. So smart contract code itself, like you're not writing a lot of code, but there's a lot of stuff to think about, right? At bare minimum, once you're done, right? Like I said, you cannot go back and change the code. So you need to make sure like you have one shot at this, right? Now there are ways to upgrade contracts. We can discuss that later, but for the most part, it's a good mindset to have, right? Like you have one shot to get it right. You have to think about flash loan resistance. A lot of like, I would say a good chunk of my code that I write on a daily basis is to make sure like we're not going to get manipulated. You got to go through audits, right? So it's difficult, insanely difficult to develop, and its development cycle is very long. Typically, it's slow, right? You have severely limited resources. The bytecode size for a contract is limited to 25 kilobytes. Okay, your stack, you cannot have more than like 15, 16 variables defined, right? The stack is very shallow. It is just overall very limited. It's not something that you can cram a lot of code into. Now there are always like proxies and routers and proxies after proxies after proxies, but still like you have limitations, right? It's not like as it's not like traditional software where you just code and you don't have to worry too much about like your code being too big. It's mostly like just memory consumption. But for smart contracts, bytecode size is a limiting factor. Integer math only, right? No floating point support. So before you get too carried away, like I hear people say, hey, let's do machine learning, AI, this and that, and big data on blockchain. Yeah. Let's calm down, right? Like not a whole lot of math you can actually do. Now with DeFi, we try to do what we can. With integer math, we try to encode some fixed point math into the contract, but it's not really like you can't get too fancy, right? You don't want to like do FFT or like raise things to like fractional powers and weird stuff that you don't really, it's not, can't easily be done. Okay. And still you have the blockchain trilemma, right? So you have the problem with security, sort of like scalability and sort of like availability and all that stuff, right? So like if you want to scale, then an easy thing to do is to drop decentralization, right? Because it's decentralization, security, and scalability, right? So if typically what they do is they make it a little more centralized, that gives you a little more speed and throughput, but you're still limited by that, right? So yeah, so these are the limitations. Now, I'm not saying that we're not like evolving, but Ethereum is pretty up to date. I mean, this is what we have to deal with at the moment, right? So some examples of smart contracts: all of the tokens you interact with on Ethereum, right? The only thing that's not a smart contract is Ethereum. Right? Everything else is a smart contract, and that's why you have to wrap Ethereum. You have wrapped Ethereum, which turns Ethereum into a smart contract based token, and then that allows it to have some ERC20 functions, right? NFTs are smart contracts. All of DeFi protocols like Uniswap, Aave, Compound, a lot of these protocols are multiple contracts, right? Like Notional Finance has close to like 100 contracts. So we have a lot of contracts that we've developed, right? So yeah, so pretty much overview. We can, yeah, I can. This is all I have, but I can open up the floor to questions. But yeah, this is really kind of just we're just scratching the surface, and there's a lot more things that we can actually talk about, but I'll just stop right here.
Thank you, James. I think some people were asking a couple of questions. If you can read the chat, and,
Sure.
James, I think somebody is still waiting. Okay, let me reclaim the host. No, oh my goodness, there are a lot of people waiting for it.
Okay,
No
sure,
worries.
yeah.
Okay.
Yeah, we can talk about some of the questions.
Yeah, go ahead, please.
All right, what are some of the questions? So Chainlink.
Gabor was asking, if a smart
Okay.
contract is immutable, how can you just update, for example, V2
Yeah.
with the oracles? Yeah.
No, yeah, that's not oracles, right? So there are typically two ways to release new versions, right? Or you can call them upgrades, right? With Uniswap, for example, right? Or was that Uniswap? Or you didn't mention Uniswap? You just said V2, V3. Okay, all right.
Yeah, like Uniswap had V2, V3,
Yeah.
and oracles is not related. I just commented on the next.
Yeah, right. Okay, so let's one thing at a time. Let's talk about upgrades, right? So there are a couple of ways you can do that, right? So one approach is to release another version. Basically, build a different contract, make some changes, and release that. Now you have two contracts. They're both immutable, but you now have two. So you can call them, one of them V1, the other one V2, right? Then then it's up to the user to decide, do I want to switch, right? This is the most kind of like decentralized way to upgrade. This is kind of like the blockchain ethos. It's up to the user to decide always, right? It's like you never force me to do anything, right? Like that's so this is one way to do it. Now there are pros and cons. So Uniswap has decided to take this approach, which I really admire. I think they really follow the kind of the blockchain ethos. Now the obvious downside to this is that you cannot get everybody to migrate, because if you don't force, if you can't force people to do stuff, they're sometimes not going to do it, right? So then you have liquidity that's kind of scattered around. You know what I'm saying? Like so you forever have to carry around that V2. So Uniswap V2 will forever be used through like DEX aggregators and stuff. There's always going to be a little bit of liquidity, no matter how fancy the new version is. Some people just plainly refuse to upgrade because of tax reasons, because of other, like, I don't know, right? Like maybe they don't trust the new version. They maybe they've read the code. They know it's safe. They don't think your new version is all that good, right? So that's one approach, right? Another approach is, which a lot of DeFi protocols actually use, is to put your contract behind what's known as a proxy. Now, with this approach, you can actually just point the proxy at a different contract, and then all of a sudden you force everybody to upgrade because the proxy has the storage. That's the key part. Proxy has the storage, which stores all of the balances and everything. Your implementation contract is really just a shell. It has no storage. So you cannot even go around the proxy to use the implementation directly because you have no storage. It's all like you're going to query everything 0, right? So that kind of forces the user to upgrade, right? So that's less of a blockchain thing now, but still you have various levels of decentralization you can do. Like the proxy can be owned by governance, for example. You can have a DAO that manages it through the governance contract. You can have tokens that vote. So you can do some stuff there, right? Like the proxy doesn't have to be owned by like an EOA, like an externally owned account or somebody's MetaMask or even a multi-sig, right? Like it can be governance. So proxies can facilitate contract upgrades. So you're not mutating the implementation contracts. You're basically just deploying new ones and pointing the proxy at the new implementation. So that's one approach. Now let's talk about oracles. Right. So yes, you can use Chainlink to get off-chain data, but like I said, is it really a good idea to trust them? Right. Now they have a network of nodes because what they do is essentially they have a smart contract. They have a smart contract that they push data into. Right. Now that smart contract is only the validators or their network, the Oracle nodes, only they can push data in. Like they probably have a whitelist or some private key, like only those private key holders can push. Now that is so it's just a matter of, do you trust a network of like 50 nodes? Is that decentralized enough? Can people manipulate it? Right? I don't know how many nodes they have, but I can't imagine that it'd be more than like the number of Ethereum nodes or the number of Bitcoin nodes, right? So is that sufficient decentralization? So that's kind of, I'm not saying that they're going to get hacked or manipulated imminently. I'm just saying that you need to think about it, right? Like something in the back of your mind, like, should I just blindly trust Chainlink? Or should I maybe think twice about that, right? Another problem with Chainlink is sometimes off-chain data may not actually be all that useful, right? Like for example, when in a smart contract, if I need to liquidate some collateral, I have to go on-chain. I have to find a DEX on-chain to liquidate. I cannot talk to Binance. I mean, it's off-chain. A smart contract can't make an off-chain call. So sure, Binance may have a great price. I'm not going to be able to use it, right? They have great liquidity. I can't use it. So I have to use on-chain liquidity. And so what good is your off-chain price if I can't use it, right? So then we talk about on-chain oracles, like time-weighted average, like TWAP oracles, but that stuff is still like, it requires great DEX support, and also like it's still kind of being developed, and also price doesn't tell you anything about liquidity, and we currently don't have any kind of viable liquidity oracle for us to get some kind of on-chain liquidity information, right? So a lot of work needs to be done in that space. So that's why I'm calling it a limitation. So we have some solutions, but they're not great, right? That's what I'm saying. What was the other question? So the size.
Jim was saying the size and limitations of smart contract is a seriously limiting factors as the world that goes more ML, AL. So if so, which chain is better for that? A good question.
Yeah, well, the size limitation isn't even the only problem here, right? Like the ML and AI and all that stuff, those things require a lot of math, and smart contracts aren't really all that great at doing math right now. Their computation is severely limited. Size is definitely a problem. Now you can proxy your way out of that, but like assuming that your contract is still usable, like it's still, like you're not gonna spend like 30 million gas on that, right? Like assuming that you can still somehow use it, it still wouldn't be a great user experience, right? Like the transaction would be huge, and you'd be spending so much on gas that's probably not even worth it. Now, which chain? See, I'm not too familiar with a lot of the other chains. I do know a lot of the EVM compatible chains, but a lot of the non-EVM chains potentially have centralization issues. Like again, with the blockchain trilemma, like dropping centralization for the sake of scalability is not always the best approach. Nevertheless, you can look into Solana, but I'm pretty sure all of these blockchains have to have these limitations in place. Otherwise, they can get attacked pretty easily, right? Like imagine if ETH didn't have these limitations. If the contract size limitation wasn't there, then the blockchain would become so big that it's not going to fit into a node or a reasonable node. If there wasn't a computation a limit on the computational complexity, then you would be able to cause the validator to go into an infinite loop, right? So there has to be some limits, right? And that's just the way the whole system works. And currently, a lot of this stuff is being done off chain. So before you get all excited about your awesome new metaverse game, just so you know, a lot of that stuff is off chain, right? So maybe only a small portion of that is on chain. There's a reason for that, right? Like your fancy game is all still traditional off chain client server kind of architecture, and there's a little bit of like a minute bit of like a couple of NFTs that are sitting on chain with the NFT data are still being stored off chain, right? You know, only the ID is stored on chain, right? So yeah, everybody needs to really kind of understand the limitations. It's not, I'm not saying that we're not going to try to make it better or evolve. I'm just saying that currently we do have this problem, right? So yes, notional loans are all on chain. Yes, all smart contract managed, no custodial stuff there. We do use proxies. I'm gonna come clean with that, but proxies are owned by governance, notional governance, right? Yes, ML, you can search variants. I'm just giving an example. I'm not saying that you should be doing ML on chain, right? I'm just giving you an example. Maybe you can train the models off chain and then maybe have a, but even with that, you just can't really do much math on chain. So I would not do any of that stuff on chain. And yes, L2, yes, potentially. Yes, that is a great point. Now with L2s, I see some of the L2s, I don't actually know the math behind some of the L2s. So like going back to the blockchain ethos, right? Like trust but verify. Well, with ZK Sync, I don't know if I can verify that. Like I don't know if the math works. Like zero knowledge proofs. I'm not a cryptographer. Right, a lot of the like smart contract code I can probably verify, like if the code is fishy or not. That's about it. Right, like ZK Sync, I don't know if that works or not, right? Like so apparently yes, with L2s you bundle a ton of transactions together and you generate some kind of proof and you post that on chain and on your layer one, right? Does the math work? Oh no. I mean, it's up to you to verify if that math is good or not, right? Yeah, polygons is I see the thing about Polygon is so first of all, Polygon is kind of like a side chain, so they maintain their own security. So the security is not really all completely provided by Ethereum. So I would not call that strictly call that an L2. also with Polygon requires bridging, right? So bridging is a kind of a in my opinion, is kind of the weakest link when it comes to a lot of these side chains. Now with Polygon, the bridge, there's that multi-sig issue, right? A lot of the bridges that have been hacked, actually, right? With because you with a bridge, you essentially have two smart contracts. You have one that's sitting on the host chain, and you have the other one that's sitting on the side chain, and then you have some kind of network POS, like a POS network that sits in between, right? That observes the events, right? And then that can go and that can mint and release tokens and whatnot. That is a great spot for attacks, actually, right? And we have seen quite a few bridge hacks. I'm not saying that this isn't like something that we'll be able to overcome, but as kind of with the current level of technology that we have, the bridges are not the most they don't really have the best kind of security at the moment, right? So I would like wait for more like better like bridge designs before getting into like all of these side chains.
I see Boyd has a question. Raise your hand. Boyd, please.
Oh, hi. Hi,
Go ahead.
James.
Hi.
From what you have said so far, it doesn't look very promising.
Why is it not promising? Actually, I'm
because
only
of-
highlighting the limitations. I'm not
the
saying that.
Yeah, I understand the limitations, but how do you see the smart contracts evolving, to be, so mainstream? How do you see them growing to, such an extent that they'll be acceptable and, user friendly, so that everybody's going to use them because of those limitations and the technology? You're in the space. How do you see that evolving over time? Is that going to grow? Or...
Yeah. So first of all, right. So I don't think it's all this stuff, especially DeFi, is ready for prime time just yet, right? Like despite what people want to believe, like this stuff is highly experimental and we're still working on it, right? Now, so smart contracts already have a lot of benefits, right? Well, I'm just saying you have to keep the limitations in mind, but the limitations don't really prevent the benefits from like outshining traditional finance. Like, give me an example, right? Like Celsius, the lender, the kind of insolvent lender, they have decided to pause withdrawals. So the clients cannot take money out of Celsius, but they have to use what little money they have to pay off DeFi lenders. Why is that? Because DeFi contracts are secure. DeFi protocols are secured by smart contracts, which means if you don't pay the money back, you're liquidated, you're gone. Your collateral is gone, and then there's a liquidation bonus, right? So DeFi contracts are above the legal system. Actually, they're more absolute than the legal system. There's absolutely no wiggle room. Like legal system has some wiggle room, right? Even if you sign a contract, I mean, you guys know this. Like I signed a lease, right? Or I signed a freaking contract, but the court decided to not rule in my favor, right? Or something, right? There's some wiggle room for interpretation because it's legal text. I mean, there's always room for different ways to interpret the same piece of text, or you have a better lawyer who can argue this stuff a little bit better, right? But smart contracts don't need any of that. If the code says you don't have money, your collateral is gone. Simple as that. No wiggle room. Nobody can stop it. Like you can't have a court order. They can't stop it. Nothing can stop it, right? Like it's done. Like if you don't pay back your loan, your collateral is gone. even if you're like on the verge of bankruptcy, or even that collateral is like you can't afford to lose it or something, no ifs and buts, right? So that's a benefit in a way, right? Like and that's also like we've had some lenders that approached us, and or like funds that said, hey, we don't like the way you guys handle liquidations. Is there's no wiggle room. We want you to give us some wiggle room. See, these people are so used to traditional finance that they're like, can you not liquidate us like right away? I mean, I mean, if the contract allows anybody to liquidate, then somebody in the world can run a bot and liquidate it. There's this doesn't even have to be us, right? So there's no way to really give you any wiggle room there. So yeah.
Jim has another question. He said, does the constant software updates in theory make it like a complex software with lots of potential attack vectors and a growing technical debt? After POS, it won't even be as decentralized. So is there some merit to be the most ossified Bitcoin and a dev even with the limitation utility?
So I didn't actually understand the second part, but so Ethereum now POS, I'm not a researcher, so I'm not 100% sure if proof of stake is more or less secure than proof of work. I do know that with the merge, nothing is going to change when it comes to execution layer. It's only a consensus layer change. So all of that smart contract stuff will still be the same. So I'm not sure if these updates are not really changing how Ethereum smart contracts work, right? It's only a consensus layer change. Now, I'm not sure if am I understanding the second part of the question correctly? So are you saying that we should be developing on Bitcoin? I'm not so sure if that's a great idea, because like Bitcoin also doesn't want to change, right? So without any kind of change, you can't really even hope to evolve any of this stuff, right? Like we already know of all the limitations on Ethereum, even though it still kind of changes, right? And with Bitcoin, if it never changes, we'll never evolve any of these limitations. We'll be like even more limiting. Like the Bitcoin block time is 10 minutes, right? So at the very least, when you send a transaction out, it isn't gonna confirm anytime soon. Sure, you can maybe able to use the layer 2, but then again, we have all the problems associated with the layer 2, right? I mean, if you're okay with the layer 2, then does it even matter if you're using layer 2 like an Ethereum layer 2 or Bitcoin layer 2, right? So yeah, so that is kind of my take on that. Now we have to see, right? Like once Ethereum, I do think that it is highly risky for them to do this change, regardless of whether or not proof of stake is better than proof of work or not, or worse than proof of work. Just changing things, right? Even from like a software development perspective is always risky, especially with a network that valuable, right? Which is why they're taking their time. So don't push them, right? Like let them test all of these, do this stuff on all these different test nets, make sure like it's solid, right? You really don't want to rush this stuff out, right? Like it is risky. I agree with that. Like any kind of change is risky. That goes for like traditional software, smart contracts, blockchains, doesn't matter, right?
Absolutely. Thank you,
All
everybody.
right, no problem.
Thank you, James. You have really helped clear a lot of. So actually, I do have a question. Actually, in sort of because like as Boy previously was probably his question somehow reflected most of, let's say, non-technical people's concerns. So as you said, if there are still a lot of, I don't know if we can call it loopholes or not, or actually some lack of that, space of transparency and the governance. How so far with the smart contract, let's say the compliance or regulatory by different countries, or the verification and authentication, how do we in the end make it more applied and to the future, the business or the development?
Well, smart contracts have full transparency, so there is no problem there, right? Because everything can be audited on chain. As for regulations, most like blockchain systems are kind of like worldwide, so they're not really tied to a particular jurisdiction specifically, right? So which is why understanding how smart contracts actually work is important than just relying on some kind of UI to interact with the blockchain, because a lot of these UIs are developed within a specific jurisdiction, right? So if the government starts to pressure on the team kind of working on the UI, then they potentially need to geo-block or like KYC or whitelist. But the smart contract that's deployed on chain, that'll forever be, at least the current ones, right, will forever be open like that. There is no way to lock them down. If you know how to interact with smart contracts, like directly, right, through a node, it's basically you always kind of, the gate is always kind of wide open. Like there's never really any problems on that front. Now with the UI, now here's the thing, right? Which is why I think DeFi isn't quite ready for prime time just yet. I do think, I'm not gonna go like on the extreme end where like you have to be a smart contract dev to use DeFi. Like that just sounds kind of weird, but like it certainly helps, right? It certainly, like it is, like this is at a stage where like think about when like cars were first got invented, right? You probably had to be a mechanic to drive a car, or at least you had to know your way around a car to drive a car, right? Like that, we're at that stage where it's better to actually know how it works in order to use it. We're not at a stage where you can just kind of kick back and relax and say, hey, all right, everybody, somebody else is handling this for me. I'm just gonna make some money in this space, right? That, like we're not there yet, right? Like I feel like this is kind of the hands-on phase where it's better to understand how it works. I know it requires some work, right? Who wants to do work, right? It requires work, but if you actually sit down and actually do the work, it'll definitely pay dividends. I'm pretty sure about that.
Absolutely.
Yeah.
Thank you. So, in fact, our session should be ended by 8, and it seems today we have so many, people are interested in this topic. Let's just answer one more question. In fact, I think, Ruthie, your question has been addressed by James previously, and he was asking this question. Not sure it was answered during the Oracle to Chainlink discussion. Smart contract cannot be self-contained in this ecosystem forever, right? So it hasn't been brought in, utility.
Yeah. So Chainlink does allow you to even call random APIs. You probably shouldn't do that, but it does allow you to do that. So yeah, I mean, yeah, but we need to really take a hard look at like kind of how these Oracle networks are designed, right? You're welcome to build an Oracle network if you want, right? Or like do some research on that and potentially like build something that's more resilient than Chainlink, right? So yes, I agree. Like we do have some solutions to allow you to call APIs not directly. Like you specify what APIs you want to call in a smart contract when you initialize it, and then Chainlink makes the call and then pushes submits things into the contract, right? There is a kind of this is like a horrible idea. Like having a smart contract depend on a trusted third-party API is like one of the worst ways to do smart contract stuff. So I really don't think you should do that. If I were if somebody were to bring that up at a meeting, I'd be like, get out of here, right? So yeah, so like yes, so it is possible, but it's a very bad idea, very bad idea.
And then Ruth, if you probably unless it's challenging, accept it. So anyway, I'm joking. Okay, great. Does anyone have any more questions? If not, I really appreciate James' time and your knowledge and experience really clarified a lot of people's concern and doubt, everything. And hopefully you come back later on. We have just again, this topic is really too comprehensive, and then they have so many variation and then applications. So again, if you're interested in different variation on this topic, please bring it up in our chat group and Telegram. Otherwise, again, thank you very much, James, for your time and efforts. And we'll see everyone next another Thursday. Thank you, everyone.
Cool.
Bye
See you
now.
guys.
See you.
Bye.